Hi guys, welcome back to my channel Tech with Hari. I am Hari. So today we are going to see how we deploy our three-tier web application in AWS EC2 with the help of Terraform. Before I start the video, if this is your first time in our channel, don't forget to subscribe. Let's start the video. Here you can see the web application that NoteZipper. Yeah, this is the application today we are going to deploy in our EC2 that Notes profile, my notes, and here you can see my profile. Here I can add all the things which I want, and I can add the photo also. I can able to update. I already updated. I go to the NoteZipper. Here I can able to search. And this is not the application which is done by me. I got this from open source. I added the link of this repo in the description. Don't forget to visit that. Imagine if we are trying to create all the resources, VPC, Internet Gateway, Route Table, Subnet, EC2 instance, by all your own using that AWS actual graphical user interface. It have a chance to be do some mistake by us. So to resolve that issue, we are using the Terraform. Terraform is nothing but a tool which has helped us to write the actual infrastructure as a form of code. Example, instead of creating that route table, we are declaring, okay, what are the things we actually want to create in route table as a form of code. Then the Terraform will communicate with our AWS API and create a resource instead of us. Cool, right? So here, by doing this, the chance to do some mistakes is so less, as well as is there any mistakes also, uh, Terraform will say, okay, you done this mistake, so do the correction. And at the same time, if you are creating this all instance by your own, by deleting all the resources one by one is actually a difficult thing. Sometimes we forgot to delete something, and for this setup, it's not that much. But if you are doing all the services manually, and if it's a lot service, it costs a lot. So to resolve this issue, we use in Terraform, we use the command Terraform destroy. By using the single command, it will destroy all the resources which we created in our cloud provider. Okay, let's start the demo. Uh, First, here you can see the Terraform file structure. Here you can see this is the Terraform thing. I already have that application in my local host. By running this, I show that how it run in my local, but I don't want that. Here you can see. So before I explain the code, I just want to say the file structures. So this is the main.tf. Main.tf is it's like a main file for our TF. Basically, for Terraform, we use the extension of TF. So in main.tf, we are just mention our cloud provider as well as what are the resources we can create. And the second thing is variable.tf. Imagine if you are using that, if now for today, if you are using AWS region as US East 1. But in other time, if you want to do the same step, but in the different region, every time doing hard code it's not a good practice. To resolve this issue, we are using variable.tf. So inside the variable.tf, we can mention all the variables with the values, whatever we want. And the next thing is output. Uh, Output is like, for example, if you are running your EC2 instance, you need an IP, right, to check whether the IP is actually working or not. Sometimes if you don't have any console access, as well as if you don't get, you couldn't able to log in with your account, by using this IP, you can able to see whether your application is working or not. So for this, whatever the thing we actually want from that infrastructure as a code deployment, we define here. And the next thing is TFS. TFS is nothing but in the variable we mention the value, but sometimes instead of creating one environment, if we need to create three environments like the test and the production environment, for the three things we couldn't able to create three files. So to resolve that issue, we are just declare the TFS file. Inside the TFS files, we mention the actual value. Then our Terraform will take the value automatically. Here this is actually created by uh, uh, Terraform itself, and Terraform.tf state. TF state is very important file. It's like a heart of Terraform. So whatever the changes we done, the status of that, the state of our Terraform will update here. And that log.hcl, Terraform.log.hcl is basically a package like a dependency file which is created by the Terraform itself. And I think that's enough for us to work with this application. Here we start. Here I explain the code first. Here you see that provider AWS. Here we are just mention which cloud provider we are going to use. I just want to use AWS. So I just mention provider AWS. Here the region is var.aws region. In my variable.tf file, I already mentioned that AWS region. Then we create a VPC. And one more thing, if you are not familiar with at least one of the cloud provider, don't go with Terraform because it's too tough for you to understand Terraform without cloud knowledge. So just go to any one of the cloud provider and just explore how we create that VPC subnet and the basic services manually. Then you can able to understand to write a code because infrastructure is nothing but it's not a magic. It's just we are writing a code what we actually perform in our GUI manually. Here you can see the resources. I just first create the AWS VPC and I just it's an actual service name as well as this is that variable name for that VPC. Here you can see I just AWS hyphen VPC. For this, don't forget to install some of the extension. This is actually very helpful. HashiCorp and Terraform. Yeah, these two instances are very important. Don't forget to install. Then sided block. Sided block is we are just mentioning that what IP range we actually expect to create our VPC and enable DNS hostname. We keep it as true and enable DNS support is true. So this both for like we'll get the DNS name for that EC2 instance. Like not only EC2 instance, we are just whenever we try to communicate with our VPC, we just need a DNS. For that, we are just enabling these two. And the next thing is we are creating a subnet. And in the subnet, we are just creating the subnet inside the VPC. So we need to mention the VPC ID, AWS.VPC, NoteZipper VPC. Here you can see the AWS VPC, NoteZipper VPC. We are just mentioning the ID of the VPC inside the subnet and the sided block. So for this demo, I just use only one subnet, but in real time, it's not like that. We are creating many subnets. So for that, we need to mention inside that sided block which range this subnet will get. So I just go with 10.0.1.0/24 and map public IP on launch. It's true and the availability zone. So basically in subnet, we are just choosing availability zone. Inside the region, which availability zone will create. And I just go with var.aws region. Here I mentioned US East 1. So here inside the US East 1, it's just create availability zone A and the tag. Then we create an internet gateway. Internet gateway is like a guard. So if the internet gateway provided that access only, we can able to communicate with our all AWS resources. So internet gateway is must. So we create a internet gateway inside the VPC and the route table. Route table is basically redirect all requests to that subnet. Here you can see we are just creating the AWS route table inside the VPC and the route for we just mentioned the sided block, which means everyone from the internet can able to access with that internet gateway as well as the cider. And here the gateway. So we are just gateway ID, AWS Internet Gateway. We are just mapping that Internet Gateway with our route table. Then only the all incoming request from Internet Gateway is routed towards the route table using this. Here you mention the gateway, AWS Internet Gateway NoteZipper IGW.id because we need to connect our route table with our internet gateway. Then only internet gateway know, okay, to whom I redirect the request to. So for this, we need to mention this and create route table. Here, this is the main thing. The route table, we need to add the subnet ID. Okay, as like in the diagram, here, the route table and the subnet, we need to mention that in the route table with like which subnet I need to communicate. For that, we need to add the subnet in the route table. Here you can see the subnet ID, and the route table ID. Here you can see create route table association. We are just creating that route table as well as the internet gateway. But for that association, okay, I already have a route table, but with whom I need to communicate. For that, we create a route table association. And after that, resource AWS security group. Security group is nothing but it's like guardian. Like say who can able to who can enter the building and who cannot. So for that, we are just mentioning which port the EC2 can access and which one or not. Basically, it's like a least privilege. Whenever which port we want to access, we need to add all the inbound, outbound traffic routes. Inbound is nothing but from outside it's coming to our EC2, and for outbound, the EC2 itself communicate with the internet. So here you can see ingress from port 80 And I just basically for in Terraform language, inbound is we are mentioning inbound as ingress, and for outbound we are mentioning it as egress. And here for this, I just allow that HTTP and HTTPS. For the SSH connection, it's default. We need to mention 22. And for Node.js backend, we allow that 5,000. And for that React application, we allow 3,000. And we allow all outbound traffic because it won't got any issues with outbound traffic. So we are just going with default. And here we create a EC2 instance. Here you can see AWS instance, EMI, var.emi ID, and that instance type is T2 micro because this is a simple application. So for this, T2 micro is enough. And subnet ID is subnet ID, VPC security group. This all are we get from the above thing and the key name. Here we need to create a .pem file in our EC2. If you don't have, kindly check with our channel. I just mentioned how we create a PEM file and EC2 instance in our AWS account. Here we need to mention the key par name of the like. Here this is the file name of our PEM, and here user data. Here you can see this is the user data. It's like what it actually will do is while the system is bootstrapping, some program will run and you can get the output without installing it all the packages and dependencies or whatever you want manually. I just go with that user data sh. Here, this is a file. I'll explain you later. But here, I just need this two environment variable. So I just added that. And don't forget to add any tags because tags are very helpful in AWS. Whenever we want to delete or grouping our project, tags plays an important role. Really, I go with for this instead of Ubuntu. This is the first time I take that Amazon Linux. So we are just install all the packages and dependencies we actually want. And to run this application, we use Node.js installation, and we are verifying this. And we are just creating a simple one directory, and inside the directory we are just cloning that actual our application. Then we are go to our front end and we are installing all the node packages and node models we actually want. And here this we create an env file, and here this in mongodb URI or previously I showed right that mongodb atlas. So you need to go to your mongodb atlas. Here you go to your mongodb. If you don't have, you just go to here, and you need to create a database. Just create a just create a new project. Then if you create a new project, I just give some dummy name, dummy project. Next, I just create a project. Here you need to create a cluster. I just go with 3, cluster 0. I just choose the AWS, then create deployment. And yeah, this username password is okay for me. Choose the connection method. Choose a connection method. I just go with drivers. Here, add your connection string into your application code. Here, it provide a application URI. You need to paste it. You need to copy it from here, then paste it in this. If you actually, this is the in for this project, my main motive is to create an infrastructure. So I'm not consider any of that ENV, but in real time, it won't like that. So for this, I just give my actual link here. But later, this after this application deployment demo, I just delete all the things. So this is my JWT secret. Then I just use the PM2. So Apache is one of the features. So PM2 is used for like reversing our request as well as is there any system crashes happen, it won't let our application goes down. So to prevent that, we are using PM2. We are just installing all the thing we actually want the PM2 server thing. So this is my actual user data sh. So this all code is available in my GitHub. I attached a link in the description also. Now I just go with the deployment thing. CD node. Now the first command we need to do is Terraform init. So basically what Terraform init will do, it's initialize the Terraform inside your application, because Terraform won't know whether your application can have any packages, dependencies, or running files of Terraform. So to initialize all the things, we use Terraform init, initialize the backend. Here you can see, yeah, Terraform has been successfully initiated. You may now begin your work. Actually, I already initiated that, so it won't take any time. Here, the next command is Terraform plan. So basically, Terraform plan is a review command. Uh, Whenever you want to see, okay, these are the things my database, like the Terraform, going to create. In that case, Terraform plan command will use very much. Here you can see it will create these much thing: AMI, AR, and resource AWS instance. For the AWS instance itself, it create these many things, and for internet gateway, it will create this. So we can able to see, okay, what the actual thing our Terraform will create. So here you can see changes the outputs. We can see public DNS and public IP. Here, the next command is CDK apply. CDK apply is the actual command which create our all AWS infrastructure as a code command into our AWS account. Okay. Oh, I'm sorry. Okay. I sorry. I just work with CDK as well as Terraform. So most of the time I just use with CloudFormation template. That's why I got a confusion. Terraform. Yeah. Yeah, here you need to enter the value yes or no. It will take a time to create that. All applications will wait for some time. Here you can see the resources, 7 resources is added, 0 change and 0 destroyed, because now itself we created, right? The public DNS and the public IP. Here will check in my database account whether it's created or not. Yeah, it's created, it's running. Here the VPC. NoteZipper VPC. Yes, it's created. Now we'll check whether the application is working or not. For that, we'll go with this port and HTTP, my new port 3000. Yeah, guys, here this is the application. Here you can see that port, uh, that our public IP with the port. This is our application, and I hope you all like this video. So in this entire video, we are just seeing how we create that entire EC2 infrastructure, which is helps to deploy our application using Terraform. I hope you all are like this video. If you have any doubt, don't forget to comment below and don't forget to share and subscribe. Thank you.